Hello, so this is my audience here. So green architecture. You also might know it as sustainable architecture. An article written by James Wines, he wrote an article called Green Architecture. He explains that green architecture is the philosophy in architecture that advocates sustainable energy sources, the conservation of energy, the reuse of safety in building materials, and the setting of a building with consideration to an impact on the environment. So what that means is basically your building takes in consideration different aspects in order to become green. So I'm going to talk about three different things. I'm going to talk about green roofs, I'm going to talk about photovoltaic panels, and I'm going to talk about passive solar heating and cooling. So the first thing is a green roof. According to the Green Studio Handbook, published in 2010, Alison Work wrote that green roofs play an aesthetic role by extending the form. This extension of the form creates a place of refuge. So it's a place of refuge, meaning you're able to inhabit the space and actually be above the ground level and look out and into an urban environment. There are two types of green roofs. There's an extensive and a non-intensive. There's a lot of that goes into it. Extensive is a shallower one and inhabitable, and intensive is a deeper one which actually has trees and you're actually able to inhabit it and be more like a park setting. The main reason behind a green roof is to reduce the amount of stormwater and when it goes into the sewer system. So a green roof can absorb the rainwater, and then what excess water is left actually goes into the sewer system. An article written in Bioscience, the volume is number 57, number 10, states that green roofs store rainwater during rainfall events, delaying runoff until peak rainfall events is over. So again, it takes the rainwater and absorbs it until there's too much to be absorbed, and then it puts it into the sewage system. It also helps cool the building, so it acts as a thin layer above the building and helps reduce heating and cooling costs as well. The next one is the photovoltaics panels, and that is basically solar panels or PV panels, and that is a way to actually produce energy. You can produce energy on site and collect energy through the sun. And in an architectural recording, Jonah Gronchair actually said that photovoltaic panels would help become net zero, and that net zero is a building that annually generates enough energy on site from renewable resources to equal or exceed demand. So basically that means net zero on a course of a year produces as much energy as it is consuming. So you have your green roofs, you have your PV panels, and photovoltaic panels or PV panels don't have to be installed right away. They can actually be installed after the design of the building, and you don't normally just install one, you install a system of panels. So there's more than one panel that is installed to work as a system to create energy. And this helps become green architecture because it doesn't take away from the energy used to produce energy, you're actually producing your own energy. So it helps to impact the environment less. Less pollution helps the environment. The third thing is passive solar heating and cooling, and there's a lot of different strategies to do this. I'm just going to talk about one, and that's called the direct gain strategy. Again, in the Green Studio Handbook, it says that it's the most basic and simple strategy there is for passive solar heating and cooling. Basically what this is it takes the design of the building, and during the cooling season, which is when it's like summer, it actually uses a way to block the sun so that the sun doesn't come in and hit and heat your building that way. But during the winter months and when you're like actually heating the building, it takes the sun rays and it heats thermal mass, like normally concrete, on the floor and actually heats up the building. When the sun goes down, it radiates back up to the building. In a case study that William O'Brien did in 2014, he explores that on sunny days, the toolkit of passive solar heating can be a tool, but passive systems such as this need to be placed in the correct climate. You can't place this in a climate that's not always sunny, or it has a lot of like cloudy days, because then it's not going to work if you're not actually getting the radiation and the heat of the sun in the building when you need to get it to be warm, then the building won't be passive solar heated as well. So you're relying on the sun to actually heat and cool the building instead of relying on like mechanical systems or like your air conditioning or heater to heat the building as well. So in conclusion, we have the green roofs, which are on top of the roof, which you can inhabit or you can't, but it acts to help with the stormwater rain into the sewage. Then you have your photovoltaics, which actually help produce energy and take away from using resources, which can help create non-pollution because you're creating the energy on site. And last is your passive solar heating and cooling, which was when, like I said, you use the sun's rays to heat and cool the building. So we can all look at buildings in one way or another, thinking it's interesting or aesthetically pleasing, but in the end, that's not really everything that matters. What's important is how it affects the environment, and from one building isn't going to do it. It has to be on a global scale. So thank you. Here's my audience.